back to learning about stuff we need to know for proofs. So you see a triangle like this. What do you know about the triangle? What do you think it is? Any ideas? You know that well, first it's going to turn out that this is an isosceles triangle. It is. But you know, sometimes it might not say it in the directions, so you don't want to necessarily conclude that. But what can we conclude, right? If these two sides are the same, what's up, Natalie? Perfect, and that's going to be one of the more important things we learn about. Yep. If these two sides are the same, the angles opposite those sides are the same. So if you see an image like this, angle A has got to be the same thing as angle C. Whoops. And the reason, if two sides of a triangle are congruent, then the, whoops, angles opposite are. Let's take a look at the difference between the two problems now on the board, right? In problem over here, triangle ABC, all it told you is that two sides were the same. It didn't say anything about being isosceles. If you know two sides are the same, then you know two angles are also the same. But here, literally, they tell you it's isosceles. It is isosceles with BA congruent to BC. Okay? What do you know? It's the same image, right? So tell me again what you know. I'm just going to put a little new vocabulary in there. Daniel? Of course, angle A is congruent to angle C. And right now we're going to talk about a few things, a little bit of vocab, right? These two angles over here that are congruent, since it's an isosceles triangle, these are going to be called base angles. This is a base angle. Do you guys know this a little bit? Does anybody also know the other piece of vocab you might need to know? Like those two are the base angles. What's that top one called? I'll give you a hint. It starts with a V. Maybe you heard it before. Shoot. Yeah, this one up over here, this angle B, this is the vertex angle. And the tricky thing is that in the directions to a lot of the stuff we do in this class, they're not going to show you a picture. They'll just say, oh, one of the base angles is this. What's the other one? Now, you see there's two sides that are the same? Yeah? Guess what? Does anybody know what those sides are called? Starts with an L. Shoot, Chris. Yeah, these guys are called legs. Legs. So there we go. There's all of our new vocab for an isosceles triangle. And the reason that you could justify angle A being equal to angle C is that base angles of an isosceles triangle are congruent. Hannah, what's up, girl? Ray AC. No. And you can't call, be careful, Hannah, because by definition, a ray has like a little arrow at the end, like a ray of sunlight flying off. Nope. All you're really going to be concerned with is that the two legs, base angles, vertex angle. Jenny? Yes. Well, I would say yes. It's almost implied. I can't see how it would be used in any other, but you have to be careful because, you know, that word base angles is also in like an isosceles, trapezoid, things like that. But that always comes with the word isosceles, yeah. Finally now, so we're getting some crazy stuff, crazy stuff. Triangle ABC with angle A congruent to angle C. What do you know if you see a diagram that looks like this? Ben? Ooh, you see, by definition, an isosceles triangle, really the word isosceles speaks about the sides, not necessarily the angles, but we're going to get to it, right? We're going to get to it. There's something we have to say first. Yep. Perfect. And so this is going to be our first step towards kind of proof. So BA is congruent to BC. And how would you justify something like that? Also, Danielle.
Because the two angles are
You're amazing, girl. If two angles in a triangle are congruent, then the sides opposite are congruent. Bless you. Then the sides opposite are congruent. Yep. And now, Ben, bless you. Bless you. And let's go big screen for a sec. I'm sure people are going to have a hard time seeing that, but that's all right. Right? Now that you know two sides are congruent, Ben, what can you like conclude? Yeah, triangle ABC. Let's go back to big screen. It's just easier to write. Triangle ABC is isosceles. Whoops. Yeah. Sorry about that. This should go on your sheet. You'll see something like that. Is isosceles since it has two congruent sides. Ah, here we go. Did anybody need more time on the other page? Hannah? All right, back to work. Triangle ABC. So BD is in altitude. What's it mean to be in altitude, and what defines it? It is. It's the line that really does define the height. But we talked a minute or two ago, right? You asked about straight lines, Mike, and I said that it came up when you're flying in a plane. How do you decide the altitude? If you call something the altitude, it must absolutely, with 100%, make that at the bottom. And what's that symbol mean? Shoot. It means it makes a right angle. So if something's called an altitude, that happens to mean that we'll call this. Oh, I should actually write it out. Angle ADB and angle CDB are right angles. Yep, straight off the bat, you know that. If you wanted to, the reason that you could use to justify this is that altitudes form right angles with the bases after this. We're almost there. We're almost there, I promise. I know it's boring. I know. Boring, boring, boring. You know what I mean? Okay, come on. We could do it. We're almost there. Ben. AD and CD are congruent? How come? I know what you're going at. You're trying to use this idea of that we used in isosceles triangles here, right? The two angles they formed aren't inside the same triangle. They're inside two triangles within one. It's not the same, you see? But what do you know? right? These two are right angles. What do you know about all right angles? Nope. Nope. Yep, that's true. They do. What do you know about them? They are, shoot. That's true, but that's not what I'm looking for. All right angles are, starts with a big C, Chris. They're what? I'll give you a hint. Whoops. A, ADB. You yell it out when you know what I'm going to write down. Yeah, these two are congruent. That's one of the more important features of this. And CDB, they're congruent. Why? Because all right angles are congruent. There's no difference between them. All right angles are congruent. Yep, all right angles are congruent. All right, last one on the sheet. Last one on the sheet. So it turns out that BE is a median to AC. We studied vocab. That was your job. What does it mean to be a median? Danielle? Sure, talk to me about that. BE is a median. BE is a median. So what does that mean about E? That's true. And if E is the midpoint of AC and this is the median, what do you know about AE and EC? Jenny? They're congruent. Yeah, that's what it means to be a median. It divides the line segment into two congruent parts. So AE is congruent to EC. And median divides a line segment into two congruent parts. That's it. Sure, absolutely. You don't mind if I do this. If I put these two lines in here, right? And also I put like a number 1 and a number 2. I'll tell you why. You can take a cheap shortcut. Instead of labeling them by their letters, which if you screw up you will get wrong on a test, if you label them by their numbers, like number them up, then you won't run the risk of like mixing up the letters. So we're going to say angles 1 and 2 and angles 2 are right angles. Right? That's my statement. I'm telling you. And then somebody comes along like Dale, and Dale's going to go, right, how do you know? Somebody tell me how you know. What's my reason for it? Lisbeth. You're amazing, girl. Perpendicular lines form right angles. So can you see how now all the stuff we did, you get a proof, and this is exactly what you write down. What else can you tell me? Just out of curiosity. Shoot. Tell me how you know that. How do you know? Ooh, be careful, buddy. Where did they say it was the middle? It looks like it. You know what I mean? I did that to mess with you. Ben. Yeah, well, you're saying the same thing as me. Angle 1 is congruent to angle 2. Tell me why. You're the man. That's just the justification I'm looking for. All, whoops, number 2, all right angles are congruent. Mike, I like what you said before. I like it. Don't get caught up in it. Be careful. Okay. Okay, so let's play again. You're given a triangle. DG is the bisector of angle EDF. So let's do our statement and reason. Danielle, what are you going to tell me, girl? What do you think? D, you got to be careful. So when you go around and you try and list an angle, it's got to go like around like this. Like the letters that you give, if you're telling me you want this angle and this angle, you know what I mean? Then it's got to go EDG is one angle and GDF is another.
So,
Or you could do something real crazy like this.
okay.
You know what I mean? And people seem to like that idea. And then they'll say, you know what? What do we know about angles 1 and 2? What do we know? Any ideas? Sam. Sam, why are they congruent? You're amazing, girl. An angle bisector, and you could say it in your own language, divides an angle into two congruent angles. Are you guys okay with my symbols?